How do we know whether to use the central limit theorem or just compute our probabilities as normal? Look for key hints in the problem to make the determination. When you're reading the problem, look to see if you're asked for the probability of a single value from a normal distribution. If you are, then just compute as usual. However, if you are asked for the probability that the mean of a group will be a certain value, then you'll be applying the central limit theorem and use the adjusted z-score. Let's apply this to an example. Let's say we're given the population of men that has a normally distributed set of weights that has a mean of 172 pounds and a standard deviation of 29 pounds. And let's find the probability that if we take one man out of the population, let's find the probability that his weight will be greater than 175 pounds. Look for the key hints in the problem. Is this a single value or the mean of a group? It's a single value. We're looking for the probability that the weight of this one man is greater than 175 pounds. Since this is a single value, we're going to use the regular z-score formula that we've been using all along. And that formula is the x value that we're given minus the mean divided by the standard deviation. So let's calculate that. If we've got one man and we want to find the probability that his weight is greater than 175 pounds, let's see what that probability is going to be. The first thing we always want to do is draw our curve. Mark your mean in the middle, which for this problem was 172. We're interested in a value of 175, which is going to be to the right of the mean. And we want to know the probability that will be greater than 175. Before we can look that value up in the normal distribution table, we have to standardize this score and convert it to a z-score. So the formula we said we would use is z equals x minus the mean divided by the standard deviation. And remember, since we're to the right of the mean, we know we want a positive value. So we're going to subtract 175 minus 172 divided by 29. You'll know you've done it backwards if you get a negative, because you're sitting to the right of the mean, you're a number bigger than the mean. If you do that arithmetic in your calculator, you should get a z-score of 0.10. When you look that value up in your normal distribution table, you find that the area that correlates to 0.10 is 0.5398. 0.5398 is not the value that we need, because that value corresponds to this area right here in our z-score table, or in our normal distribution. But we want the area in this right-hand tail. So in order to find that area, we just subtract what we have of 0.5398 from 1, and that'll give us the remaining area that's in the tail. And when we do that subtraction, we get 0.4602. So the probability that the weight of one man will be greater than 175 is 46.02%, or 0.4602. Now, let's say we have 20 different men and selected from the population. Let's find the probability that their mean weight is greater than 175. Now, in this case, we're talking about a group of 20 men, and we want to determine whether the average of their weights is going to be greater than 175. So look for our key hint. Are we talking about a single value, or are we talking about the probability that their average will be a certain value? We're talking about the probability that their average will be a certain value. So we're going to be able to apply the central limit theorem. If we apply the central limit theorem, then we're going to use our adjusted z-score. If we can use our adjusted z-score, then we're going to divide by the standard deviation, which has been divided by the square root of n. Sorry. I meant to go backwards and I went forward. Notice how down here, instead of just dividing by standard deviation, I'm dividing by standard deviation divided by the square root of n. That is what makes the difference for using the z-score for the central limit theorem. Alright, let's solve this problem. As always, start with drawing your curve. And label the mean in the middle, which is still 172. And again, it's going to be the same curve we had before because we're using the same values. The only difference is that we're going to apply the central limit theorem because we're talking about a group of men. We want to know if their average weight, what's the probability that the average weight will fall in that tail? What's the probability that the average is going to fall greater than 175 pounds? So again, the difference comes into play when I calculate my z-score. So I need to convert into a z-score. I still subtract the same values at the top, 175 minus 172, but down here in the denominator, I'm going to divide my standard deviation divided by the square root of n, which is 20 because I had a group of 20. Now remember, you need to apply your order of operations and make sure that you divide 29 divided by the square root of 20 first so that you come out with the correct result. This should be done first prior to dividing into the top. You should get a z-score of 0.46. When you look up z of 0.46, you're going to get an area of 0.6772. 0.6772 is this area over here, which is not what we want. We're interested in this area over here. So I need to subtract from 1. Which gives me 0.3228. See, if I added these two areas back together, I would have the total area under the curve of 100%. So the probability that the mean weight of that group of 20 men being greater than 175 is 32.28%. When you're looking at your problems, again, the key is to just look at your problem and try to determine what it's asking for. The key words you want to look for are whether you're looking for a single value, probability as it relates to a single value, or probability of a mean value. That will tell you whether to apply the central limit theorem and use the adjusted z-score, the one that uses the standard deviation divided by the square root of n, or whether to use your regular z-score.